Hey guys, good morning. Hey, we're going to go over some calculator usage. This one won't be very long, but because I'm going to really hammer down how you use the calculator. So, normal calculations in the calculator. Second, vars, which is right below or right next to clear on the calculator. We're gonna go into the distribution mode, and then you want to want number 2, which is normal CDF. And so your calculator will display it in some sort of fashion to where you have a lower boundary, an upper boundary, a mean, and a standard deviation. So in the TI-83s that you get from the calculator, from the library, you're going to put them in parentheses with commas, just like this. And that's how you're going to kind of find your values. So let's tackle this first one right here. So this first one, I already pre-labeled it for you. Remember, the best thing to do is always draw your distribution. I want the area over 100 miles an hour. I put my X bar in, I put my standard deviation in, and then my upper boundary. So if you have no upper boundary, I just put in 9999. Makes it easier. So now I've got all 4 pieces for the calculator, okay? So I've got all 4 pieces. Now, what is acceptable on the AP exam? Just putting in the calculator is not acceptable. That's one of the issues that people run into. So this is how we do it. So now I've drawn this. So somebody grading this knows that I know X bars in the middle. I know the standard deviation. I know what my lower boundary is and upper boundary, and I'm looking for this particular area. So they know that you're looking for the proportion. They know what you're doing now. So now the question is, how do you write it? I just write it like this. The probability that the z-score is greater than or equal to 100 minus X bar all over the standard deviation. So basically what you're saying is that you know that the X, this is the z-score formula. That's a 2, guys. This is the z-score formula. So you've just shown them that I know how to calculate the z-score, and then you can just put the answer right here from your calculator. So let's not forget, let's kind of do a quick run through on how to do the calculator. So we're going to hit clear. We're going to do second distribution, normal CDF. Lower boundary for me is going to be 100. 9999. Standard X bar and standard deviation, and enter, and then you hit enter, and we are going to say approximately 0.13%. So 0.13% of his pitches are faster than 100 miles an hour. Okay? All right. So let's tackle this one. Same idea, except now we have a lower boundary and upper boundary. Your X bar and your standard deviation is the same. So let's practice writing this the way we're supposed to. So we want the probability that the z-score is less than or equal to 90 minus 94 all over 2. And then you can just put that in your calculator. So again, we're going to change it up a little bit. We're going to go back to normal CDF here. And then our lower boundary is negative 9999. Lower boundary, you don't have one, so we're going to make it really small. 90 is my upper boundary. The mean and standard deviation stay the same. So then I hit that, and I get a probability of 0.0227, so approximately 2.27%. That's a proportion that travel less than 90 miles an hour. So again, we're back to between, and this is where the calculator saves your time. Don't forget to draw your distribution, label it. We now know that I have an upper boundary. I have, oops, sorry, that's a lower boundary. I have an upper boundary. I have my X bar and my standard deviation. Now, this is a little longer to write, but it actually takes a little less time. We want to know the probability. Oops, I messed that up. The probability that the z-score is in between 93 minus 95 over 2. 94, sorry. 94. 94. And we want to know that z-score is also less than 95 minus 94 over 2. And then we can put that in the calculator. And so if we practice putting that in the calculator again, we're going to go with, I'm covering it up right there. So let's look here. Clear distribution 2. My lower boundary is 93. My upper boundary is 95. Everything stays the same. And we hit enter, and I get approximately 38.29% of his pitches are between 93 and 95 miles an hour. So that's my lower boundary, my upper boundary, and then my standard deviation. And that's how you write it for the test. If you do that, you'll be fine, especially if you draw your distribution. So this one's a little bit different. Fastball velocities would be considered low outliers. So now we got to find our outlier boundary. Whoops, my desk actually moves. That was kind of crazy. So we have to find our IQR. How do we find our IQR? We have to find our Q3 and our Q1. So that's Q1. 25% of the data, 75% of the data. So now we're going to go to inverse norm, because now we're given an area and we need to find the value that's with it. So if you look at this, you can draw it this way. We want Q1 and Q3, and we want the values that are in between there. So that's where this is going to come from right here, Q3 and Q1. So if we look at that here, we're going to move up just a little bit. So I want to go to second distribution. Inverse norm is number 3. So it's number 3 on the distribution. And I want to know the area. The area is 0.25. My mean is 94. And my standard deviation is, and we're going to hit that to the left. And we have 92.65. So that z-score is 92 point, not z-score, it's 92.65. So Q1 is located at 92.65. Q3, there's not a lot of room to do this problem. So Q1 is 92.65. And then let's do inverse norm again. Oops. Sorry, guys. Go down to inverse norm, 0.75. Everything stays the same. And my value is 95.34, so 95.34. So we're going to plug this into the calculator, Q3, which is right here. This is Q3. And we're going to do Q1, and we're going to multiply it by 1.5. So I'm just going to do it all in the calculator right here. And I'm going to go 95.34 minus 92.65 times 1.5. So that's 4.035. 4.035. So now I take Q1, which was 92.65, and I'm going to subtract 4.035 from it. So I'm going to take Q1, which is 92.65. And I'm going to subtract my answer from above. So I'm going to go second, and I'm going to insert my answer from the previous question. It's right there. And so if you do that, it inserts the answer from the previous question. You don't have to type it in. And it gives me 88.615. So I get 88.615 miles per hour would be considered a low outlier. Okay? That's a low outlier. All right. So this next one, suppose a different pitcher has fastballs and have a mean velocity of 92 miles per hour, and 40% of his fastballs go less than 90 miles an hour. So they give us this information, but they don't give us a standard deviation. So this information isn't very useful right now, but we also know that we can actually work with z-scores. Always, my x bar is always 0 on z-scores, and my standard deviation is always equal to 1. This is one of those concept application questions. So if I know that I have 40% of the data here and I want to convert it to a z-score, all I need to know is that I can use this as x bar and this as standard deviation, and I can plug that into inverse norm to get my z-score. So now I'm going to use the concept that a standardized score will give me an answer. So if I go to second, distribution, I go to inverse norm, my area is 0.4. My mean is 0 because I'm dealing with I'm going to deal with standard deviation. Standardized scores, since I don't have a actual standard deviation. And then I'm going to have a standard deviation of 1 because dealing with z-scores, my standard deviation is 1 and my x bar is always 0, and now my area is 0.4. So when I hit that and punch it through here, I get a z-score of negative 2.53. Well, now I can use that z-score of negative 2.533 set up into my x bar x minus x bar over standard deviation. And if I do the calculations correctly, I get standard deviation negative 2 divided by negative 0.2533. And if I do that in my calculator, 2 divided by 0.2533, I end up with 7.89 miles per hour is his standard deviation. All right, guys. All right, well, that's how to use your calculator. Good luck with that.